Hi everyone, Sanbonani, Molweni, Dumelang. In this video, we'll be sketching a hyperbola graph. Remember that we were given in question 4, h of x, a hyperbola, is equals to negative 3 over x minus 1 plus 2. So we'll be doing question 4.1.3, which is asking us to sketch the graph of h, showing the asymptotes and the intercepts with the axis. So in question 4.1.1, we found that the asymptotes were as follows. The vertical asymptote was x is equals to 1, and the horizontal asymptote was y is equals to 2. And we can draw that. The vertical asymptote is x is equals to 1. And the horizontal asymptote is y is equals to 2. Now we're asking ourselves, will the graph be on the first quadrant and on the third quadrant, or will it be in the second quadrant and the fourth quadrant? Those are the two options, right? So how do we figure out which option to go with? Remember, h of x is negative 3 over x minus 1 plus 2. We mentioned that the standard formula for hyperbola is basically a over x minus p plus q, and a is equals to negative 3, right, in this case. So because a is negative, our graph will be on the second and fourth quadrant. So we're going with option 2. There is something else though that will give us a hint as to in which quadrants our graph will be, and that is our intercepts. So let's find the intercepts. Let's start with the y-intercept. You let x equals to 0, therefore you're going to have that y is equals to negative 3 over 0 minus 1 plus 2, which is negative 3 over negative 1 plus 2. And this is 3 plus 2, which is 5. Therefore, the point 0, 5 is the y-intercept. These 3 dots mean therefore. Now, let's find the x-intercepts. You let y equal to 0, and you're going to have 0 is equals to negative 3 over x minus 1 plus 2, which implies that the sign is which implies that you use it when you're trying to separate two equations without moving on to the next line. So you want to remain in the same line. You get negative 2 is equals to negative 3 over x minus 1. You take 2 to the other side, it becomes negative. And we're trying to isolate x, therefore, we can say negative 2 times x minus 1 is equals to negative 3. And to isolate x, we divide both sides by negative 2. You get x minus 1 is equals to negative 3 over negative 2, which implies that x is equals to 3 over 2. Take 1 to the other side, we get plus 1. This is 3 over 2. You can write 1 as 2 over 2, and you get 5 over 2. But what is 5 over 2? You can write 5 as 4 plus 1, then divide by 2. You'll get 2 plus a half, but a half is 0.5, therefore you get 2 plus 0.5, which is 2.5. See, you don't need a calculator. Therefore, our x-intercept is the point 2.5, 0. And you found your intercepts. Now, let's plot them. X-intercept is here, y-intercept is 5. Great. Do you notice that this gives us a very useful hint that our graph is on the second and fourth quadrants, and we can draw the graph now. Now, let's use a graphing calculator to see what our graph looks like. So now we're just confirming if we have the right drawing or not. And this is what our graph looks like. We can add our asymptotes. You have y is equals to 2, and we have x is equals to 1. These are our asymptotes. In the previous question, we found the axis of symmetry to be x, negative x plus 3. The axis of symmetry is a line that bisects the graph. So it basically cuts the graph into half. And you also notice that it passes through the point where our asymptotes intersect, right? The point P comma Q, in this case, 1 comma 2. Do you notice that? And we can also verify our x-intercept is in fact 2.5, and our y-intercept is 5. Y is equals to 5. Great, so we have the correct drawing. You get a mark for the intercepts, so let's write them out clearly. The x-intercept was 2.5, 0. The y-intercept is 0, 5. You get a mark for that. You get a mark for the intercepts. You get a mark for the asymptotes. You get a mark for the shape of the graph. So it's in the correct quadrants, second and fourth, because A is negative. You get a mark for that.